Dear students, today we will discuss machine instructions categories. So whatever architecture a computer is using, whether CISC, complex instruction set computer, or RISC, reduced instruction set computer, the machine instructions can be categorized into three broad categories. So these three categories are data transfer group, and the second is arithmetic logic group, and the third is control group. So we will learn about all type of such instructions, that what they form and how they are decoded and encoded in the computer. So first group is data transfer group. So it deals with the transfer of data. So for example, you have learned this algorithm previously, adding two numbers. So in this, you can see that step 1 is that get one of the value to be added from memory and place it in a register. So such a work is known as transfer. So in step 1, step 2 and step 4. So these are data transfer group which is being used within this algorithm which we learned in the previous module. And then there are special terms are used when talking about transfer between CPU and memory. So let's see what are those. One is called load. So load is getting data from main memory into the register. So that was the first step within the previous algorithm. And then store is storing data from register to the main memory. And IO instruction is to dealing with the peripheral devices like the keyboard, printer, scanner, mouse. So your CPU need to send signals or need to read and write the data from those peripheral devices. So for such kind of things, there are certain instructions known as IO instructions, input and output instructions. And there is one more thing, that whatever we retrieve data or we store data, it is not moving actually. It is the copying. So when we say load data from RAM, so this doesn't mean that move whatever the data we have in the RAM into the register. We are saying that copy data from RAM to the register. So one of the copy of that data will still remain into the RAM. And then there is an arithmetic logic group, the second group, that represent an activity within arithmetic logic unit, ALU. And with this algorithm which we learned in the previous modules, the step number 3 over here is actually the arithmetic logic group instruction, which is saying that activate the addition circuitry with the registers used in step 1 and 2 as inputs and another register designated to hold the result. So such instruction is called arithmetic logic group instruction. And then there are not only addition or subtraction or multiplication that is done in the arithmetic logic unit. In fact, there are some other operations as well which are performed in ALU. For example, AND, OR, and exclusive OR. So these are the Boolean operations you learned in some of the previous modules. And then there is shift and rotate that is also performed in ALU, and we will learn about shift and rotate in the next modules. Then there is a third group known as control group, that execution rather than manipulation. So that is basically the overall in charge of the CPU that tells that at what time what need to be done. So for example, in this algorithm which we learned previously, this step stop is the control group instruction. So which is telling you need to be stopped, and then it is sometime telling some other program to start. So such kind of instructions are covered under control group. And then there are some other instructions like jump or branch, unconditional jump, and conditional jump. So such instructions are known as control instructions. So we will see an example of jump in the next slide. So for example, we want to divide one number by the second number. So our first step is load. So you can see now we are not writing that we need to get information from RAM. We are saying load. So load means load a value from RAM into the register and then load another value from RAM into the register. So now if we want to divide one number by the second number, we need to see that second number. If that second number is 0, then we should go to the step number 6, which is stop. So this means if second value is 0, we do not need to perform step number 4 and step number 5. So such an instruction is known as control instruction or jump instruction more specifically. So we are saying if this second value is 0, jump to step number 6, and if it is not 0, then we execute step number 4, divide that, and then we store. So this division is ALU instruction, and this is data transfer instruction, this is control instruction, and then storing is again data transfer, and stop is again control instruction. So if we summarize today's module, we have well learned about how are different groups in machine instructions. So different categories are data transfer group, and then arithmetic logic group, and then the control group. And we have also performed an example to see that how such instructions are forming an algorithm to actually take some work from the computer, whatever we want to do the computer.